Hi, I'm Tom Nonamaker. I build and maintain the website. I added an interesting calculator. I was watching a video on YouTube, and they're talking about CANPA, which is a constant angle non-precision approach. And the airline's been using this as part of a stabilized approach for a long time. I think the Air Force has adopted it as well, as I heard. They didn't when I was flying for the Air Force, but things have changed, and I retired quite a while ago. So I wanted to add this because it was really cool concept. So basically, if you go to flight planning, you'll see this CANPA calculator. It does a little bit more because it also will tell you what your density altitude is and that kind of stuff, your headwind, crosswind components. So let's just see what it does. So we have the airport ID. You put in what you want here. Now you can put in something like, say, Chicago, and it'll go look up the METAR for it. But in this choose, I have a bunch of local airports. So you can see the distance to Colorado Springs, field elevation, and the name of the airport. If it's bold like this, those are military fields. And I bolded Leadville just because the name of the airport does not have Leadville in it. And I know a lot of people go there for mountain flying. So we'll just put that in here, and it'll pull up the METAR automatically. If you want to get more information, let me just close those. You can just click this info link. That'll pull up the AirNav database for Leadville. And you can see it's got a runway 1634, and it even has links to the approach plates. So we can click on that, and here's the, what's this PDF? Oh, there we go. Here's the approach profile for the Leadville approach. So we've got that set. It pulled in the altitude, the field elevation automatically. Now you're probably not going to be flying at field elevation on your approach. So like in this case, say we're going to be flying, we're just trying to figure out a descent gradient, how many feet per minute do we need to descend. So in this case we've got 1.6 plus 3.1, so we have 4.7 miles. We'll just put that in, 4.7. And then the altitude difference is 13,000 down to 11,440, so that's 1,560. So 1560. So that's a 3.13 degree descent gradient. Now, at that angle, you can actually set that on your attitude indicator. Just hit the final approach fix, push it down to 3.13, and but this data you're going to be looking for this feet per minute. But let's calculate that. So now we have the METAR. We can go look at the decoded one if you're not used to looking at the raw one. And here's the decoded one. But the raw data, we have the winds 190 at 5, the temperature is 17, dew point -3, and altimeter 3032. So let's put in the temperature of 17 and the altimeter 3032. And I notice I didn't have to put in the decimal place. When I hit tab, it automatically puts it in for me. Now this is assuming we're flying a 172, which probably can't go into Leadville. So let's say we're flying something a little faster, maybe the 182. I'm not sure what the speeds are yet for that. I haven't checked out in it. Well, let's just say it's 80 knots. I'm not sure what it is. Now the winds are 190 at 5, so we'll put in 5 knots. And remember, the runway was runway 16, and the winds are 190, so they're 30 degrees off the runway heading. So here's our headwind and tailwind components, our density altitude, pressure altitude, and our true airspeed. So we're flying 80 knots indicated, our true airspeed is 96. Subtract out the headwinds, and we're going to have a 92 knot ground speed on final. This is the descent gradient that we're going to have, the 3.13 degrees down, and we're going to need to fly 509 feet per minute to match that descent rate, to stay on that 3.13 descent angle. So that's basically it. Again, you can use this choose to pick any of these local area airports, or you can just type in an identifier and it'll go look it up and fill it in for you. So that's basically it. There are some articles down here about constant angle approaches, and for doing instrument flying, pretty useful. Even visual flying, this will give you an idea what kind of rate per minute you're looking for on final. So if you're doing say 65 knots on final and a 172, and you're flying at Colorado Springs today, let's see, the wind's 160 at 11, so we're on runway 17, temperature 26, altimeter 3007, 65 knots, we're talking 11 knots, and we're 10 degrees off the runway. So we're going to have a 74 knots true air speed. There's our dead steam pressure altitudes. 63 knots on final ground speed. And our distance and the springs, let's see, we got to bring that up. So let's go info and then to the approach plate. We'll zoom in a little bit. So in this case, 7540 to 8700 is what, 1160 and 3.6 miles. So 3.6 miles, 1160. So we're looking for a 3-degree descent angle and about 338 feet per minute. So that's what you should see on final with a normal glide path. So hope that helps. If you have any questions, let me know, but enjoy the tool. Let me know if you have any suggestions to improve it, but I think it's pretty useful as it is. So thanks very much for watching, and we'll see you later. Bye.